Guys, you guys start here. You guys start here. Sorry, we have to let these people leave us. There is a video online for you already.
Bye, Miss Sun.
Bye. I'll be here for till tomorrow if you need me. Check out the website. It'll be on the okay? Bye, Nick, Brendaline. They're not in the way or anything. Thank you. Okay. So if anybody wants to move up, you can. Okay? Because we're going to do a couple more things up here, and then we're going to go outside and we'll come back. Okay? So here we go. How much iron can be recovered from 25 grams of iron 3 oxide is what that is. So what am I starting with? 25 grams of iron 3 oxide. Okay. What do I have to go to? I really have no choice. Moles, so what are you using? A calculator. First, you're using a calculator to get what?
The mass.
Mass. Okay, so in your calculator, what are you adding up?
2 irons.
2 times, what's iron's molar mass? 55.85 plus 3 times 16. So we're taking the molar mass of iron 3 oxide. We're putting 1 mole on top. Okay. And that is 159.7 grams, approximately. Okay, so that's grams of iron. That's grams of iron 3 oxide now, okay? And then we need to get out of iron 3 oxide into just iron.
So you do, okay, so we do 1 mole of
So 1 mole of what?
iron.
This guy?
Yeah.
Iron 3 oxide, because the 3 comes from iron, right? So iron 3 oxide. And what goes on top?
Just the iron.
Right, so how many?
1 mole of
No,
2 moles.
2, because there's a subscript of 2, so 2 moles of Fe, okay? And then your last step is to get from iron moles to iron grams, and that means to put what on the bottom?
1 mole.
1 mole of iron on the bottom, and 55.85, where are you getting that?
Periodic
Purity, okay. So 20. So in your calculator, everybody, 25. Next,
Divided by 159.7.
159.7 times 2 times 55.85, and
17.48.
17.49. Oh no, we still got to round further. Okay, 17.5 grams of iron. Okay, so you must make sure you cancel your units. Since the first one leads to the second one, the next one leads to the next one, next one leads to the next one. You're only left with grams of iron. Some of you guys are gonna try to take shortcuts on me, but don't, because then you're gonna mess yourself up later. I mean, you can try, but I don't want you to get yourself in a hole. Okay, so before we do percent composition notes, let's do an outside activity. Okay. So here's the rules. You have to have a thing of chalk. If the chalk's on the lab stations, you have to mask your chalk before you go. Chalk is calcium carbonate. So basically what we're doing is this thing, okay? So calcium carbonate is what it's made up of. You're going to go outside and draw chemistry, write your name, write your favorite elements, I don't know, write good things, okay? Good things. We want to keep a positive note here. Be like a proton, people. Let's be like a proton. And after when we get back, we're going to mask the chalk afterwards. You can figure out the difference of the chalk that you use, figure out what that is in grams, figure out what that is in moles, figure out what that is in atoms. Cool? It should take us no more than 10 minutes, 15 minutes max, okay? So get with a partner if you want to. Get your own piece of chalk. Doesn't matter to me.
Mass it and just write it on the lab table itself until we come back and we'll get paper. Wait, just write it on the lab table itself and we'll come back and we'll get paper. Everybody can go on that one. Wait, so you don't want us to write on that paper? You will write on the paper when we get back. We gotta go outside. So mass it now, write it down. Everybody has to do this like this. Write it down on the okay, let's go outside, guys. Wait.
Yeah.
Wait.
Yes.
We have to take a group picture. Picture? Yes. I don't know my hands. Me neither, but you know, it's all good. We have to take a squad pic. Okay, I'm leaving you people. I'm leaving you. No. Don't leave us. I'm leaving.
Kelly Scott has to do test corrections in order to get the curve, and Redmond just gives the curve. Yeah. Redmond, we don't have our first one back.
No, we already did that. We did
Last year, gardening. Last I got was gardening.
Where's yours?
Where's your measurement?
Mine is right here.
Yeah.
8. Go get actual paper now because you have to write down the math point. This is a pre-lab grade. We should be done in less than 10 minutes. Some people ain't got it.
No.
Good morning.
No, it's not. This is my stuff. Easy. She doesn't like. Why? Morgan doesn't like. Are you calling easy? It's so.
Yeah, she don't like that. It's like, go for me, man. What are you talking about?
Okay, so I'll see you up in the front in less than 10 minutes.
Yeah.
Yes.
What did you say? Calcium.
Calcium carbonate on the lab sheet.
So, grams of chocolate flash.
I can do it. I
Actually,
actually get
grams of chocolate flash.
So then you put
So it's just like what you wrote.
calcium carbonate.
How much money is subtracted to how much?
Okay, all of that.
So that's very key.
So we're
Massive chocolate flash.
started with times. So on the bottom.
So you have like the mole.
I think you put grams on the bottom.
I know, what way? Wait, what is chocolate? Yeah, I wrote it right here. C8 mass. So that's gonna be 44. So no, 12. And then plus 3 times the 16. Oh, CAC. Calcium carbonate. This is. So like it doesn't count at like there's 0 there, you count it advanced way, so it's gonna be 1, 2, 3, 4. It's gonna be like 0.47.
Okay, we're done. Pass away. I'm putting a glass of mini.
For atoms, we're gonna do 1 times 6.022 times Yeah, it's 1 to 6.1. Yeah. Sorry.
So basically, I was there. I just didn't realize what I was doing.
And then you're stopping your moles and then you start finding new atoms.
And I have to go to grams and so
We're gonna have to go with grams. Right?
it's like grams. But when I think of like atoms to grams, you're supposed to go.
So you're in moles here. You're in atoms here. Now you're taking.
The only thing I would do is copy, not actually taking the yeah, just calcium. You have to wait. Yeah. But for the multiplication, we'll just
You got it?
wait for which one? Oh, then yeah.
Okay, yes, this is number 12. This is fundamentals or actuators. This is atoms or atoms here. For atoms or units.
You have atoms.
But I use a lot.
I'm thinking about writing that down.
Are there? Yeah.
I want to write that down.
We have atoms.
So we do atoms
So have one here, so you're gonna put some mold. I don't think you want to do it from molds to. You just want to do a couple grams from there. Yeah, so it's gonna be yeah. Times this three molecules of oxygen is going to be yeah. All over one roll of carbon. And then you multiply it by the atom. One roll of on the top. And on top of the atom.
How do you mold the grams?
Yeah.
Atom.
Yeah.
I'm just like copying people.
So, take your number, the whole number, which is not really long, 7. One mole of CaCO, top you would say, house grams. But you guys could never gram. It was mole, and one mole, and 1 gram, and then you would do
Alright, guys, are you eating? We should go to some next minute.
You'll remember the internal, yeah, or the 3 substitute goes up. You don't need to.
I'll stick marks with other ones. What's it saying here?
I just looked at the ratio and then I turned it on.
Oh, no, I was trying to ask you way or something. I do it, I think like.
I was saying 6. I was
I didn't hear that.
yeah, no, we ran. Yeah, it's already. Oh, did you guys not use
I what?
Oh. I didn't. That's the so number grams calcium. Yep. Now, I'm saying it's part of the mold.
Alright, when you're done, please put it in the box.
Yeah, it's pretty important because if not, you're just frustrated. Stuff
Okay, just FYI, you can turn this in later, but we have about 25, 20, I need 10 minutes and 25 minutes of simulation. So I want you back up here done in 1 minute. Just back to back, turn off your scales. Turn off your scales, turn off your scales.
Yeah.
John or not, please come back. Come back.
If you do not put your chalk back, you will have to put it back later. Put your chalk back in the central bucket. Yay! Okay, so hold on to your lab. If you finished putting the box, but if you didn't finish, then it's cool. Then you can finish that last calculation. It should be a pretty easy last grade. Be sure though you're putting your units across the board because that's kind of like the most important thing in this unit. This unit has a lot of units. Thanks. Okay. So, my board is going to die. I hope it dies. Okay. So, because I want a new goal.
That's the only reason, or only way you'll get one.
Yes. So we the last thing we need to talk about today is percent composition. Find in your reading guide where you are taking the formula for percent composition. This part's pretty easy, but I want to do a couple of examples with you, like chemistry examples. Okay. Reading guide, percent composition. Huh? Yeah, pass back reading guide turns to 20. Yeah, percent by mass. Sorry, percent by mass. Okay, so the mass of the element, where would you find the mass of an element if you had to look for grams of it? PTOE. And then you would divide that by mass what? Mass of compound. And then do what to get percent? Times by 100. That's it. So if I had to count here, 1, 2, 3, 4, 5, 6, 7 boys out of, let's say, 21 people in here. What's percent boys in the room? So it's about a third, so 33.33%. So it's always part over whole, right? So the part is the element of interest over the total compound. So that's basically what we're doing right now, okay? So let's go. Calculators out, periodic tables out. We just did this, okay? So we got percent composition. We know how to do this. Huh? No, this part is not. This right here is not. There are a couple of other examples we might not need to do after we do this and you guys get it, let me know, okay? So I want you to calculate percent composition. And when I say percent composition, I mean the percent composition of every element in magnesium phosphate. So for each element. So what is magnesium phosphate, by the way? Mg. I hear PO4, okay, I'm cool with that, but what's in between? 3, PO4, 2, because magnesium, guys, everybody's working with me, okay? Magnesium is a 2+ charge, crisscross it down. Phosphate is a 3- charge, crisscross it down. All right, so whenever you're looking at percent composition, I want you to just simply focus on, this is just me doing the first part, okay? Focus on magnesium first. How many magnesiums are there? 3. So for magnesium, we're going to do 3 times, what's magnesium's mass? 24.31 grams. Okay? So that's just magnesium. So I saw there's a subscript of 3. I said I have 3 of them. The mass of magnesium is 24.31. Divided by the whole shebang. Everything. So I'm going to write that down here, but in the future I'm not going to write down. We're just going to calculate our calculator. So it's still 3 magnesium, so 3 times magnesium's mass of 24.31 grams, plus what? How many phosphori?
1.
You
No, it goes.
Here, don't doubt yourself. Make a decision. Be confident with it.
The 2
2.
goes back in.
The 2 distributes into the 1 on P. Cool?
Yep.
So that's 2 phosphori because there's phosphorus is phosphori. So there's 2 times 1, so there's 2 phosphori, which weigh what? 30.97, okay, grams, plus how many oxygens? Yes, they're 8 because it's 2 times 4. So that 2 distributes in. So that's 8 oxygens, each weighing 16 grams. Okay, so everybody add this up. Calculator. Okay, let's get that total mass. So 3 times 24.31 plus 2 times 30.97 plus 8 times 16.
262.87.
So this whole thing down here is 262.87. Thank you. All right, so to get the mass percent, I wanted to show you how to add that up because I know we still mess up on that whole what do you do with the 2 thing. You'll see that on your quest on Tuesday. Not this exact example, but something similar. Don't forget about distributing the 2 in. Anyway, take your total mass here, your partial mass, which is the magnesium part, over the total mass, times 100. Tell me what you guys get for percent magnesium. Just 1 second. 27.7%. Okay, so that's 27.7% magnesium. Do the same thing for phosphorus. Now that you have the total mass, that part's really easy. So now you can, after you get magnesium, you can go ahead and do the same for phosphorus. So I'm going to kind of simplify my work for this. So percent phosphorus is 2 times phosphorus's mass of 30.97, which is found on the periodic table, divided by 262.87 grams, which is our total that we just calculated. So once you get the total calculation, excuse me? Right.
And then add them together, and then...
What do you mean? Add them together and do what?
So we're going to add those together for the mass of the compound.
The mass of the whole compound was what we just did here, where we actually literally calculated 3 magnesiums plus 2 phosphoruses plus 8 oxygens, because we found what that was according to that compound formula. This is that number, though. I didn't want to recalculate. It's what it is.
So then why are we doing it again?
We're doing it for phosphorus now. So we have magnesium, which was 1 example, phosphorus, which is a 2nd example, and then we're going to do oxygen.
So,
Yeah.
So we're doing it
For each
We're
element.
not like actually solving each one.
Right. Not yet.
In this total compound, once you find the percent of magnesium and phosphorus, can you just add those together and then subtract?
Yes, because that's too much work to do a 3rd time, right? So this was what, 23.6% phosphorus. Okay, so that's what the last point is to say, once you get most of the compound done, there's 1 element remaining. The whole shebang is going to equal 100%. So to get the oxygen, you'll do 100%, subtract 27.7, subtract 23.6, because that's just that added together. So that's going to be 48.7% oxygen. Okay, so that was just the first part, right? That seems like a lot of work, but a lot of this can get in your calculator, but I want to see this set up, this right here. I don't need to see all that nonsense. I need to see this set up to give you full credit, okay? But to answer the second part of the question, if you have a 54-gram sample of magnesium phosphate, how many grams of that are oxygen? You're going to use which of these lovely values? The oxygen one, okay? So when you use the oxygen one, and the question said 54-gram sample, how much of that 54 grams is oxygen? What percent of it is oxygen?
48.
Okay, but how do you multiply by percents?
47.
You move the decimal back, right? So you do 0.487% oxygen times the total mass given to you of what? 54 grams total, and that tells you what amount of oxygen. 26.3 grams of oxygen. So most of it's oxygen, the rest of it's magnesium and phosphorus, but that's how you use the percents to figure out percent composition of a specific mass or something like that given to you. Okay, we're going to do the same thing, but not to that detail, because I think once you do it once, you kind of get it. But the percent water in a hydrate is a little different. So calculate the percent composition of water in the following compound, zinc nitrate tetrahydrate. We've done 1 or 2 examples of hydrates where it's got like the bullet point in the middle and then waters afterwards. So tell me the chemical formula for zinc nitrate. More. I hear hold on. I hear parentheses. 2 because what? Zinc is a 2 because of zinc. Z looks like a 2. Okay, that's how we remember it. So the 2 crosses down. The nitrate has a what charge? 1 minus, crisscross it down. So that's how you get that. Then you put bullet point. How many waters? 4 waters. You could literally write 4 water. That bullet point does not mean multiply. It is just a thing there that says this is a hydrate. The waters are embedded in the zinc nitrate. Because that's what the compound formula is, right there. So we have to include it because it says tetrahydrate.
So hydrate's just like water.
Yeah, hydrate means like you're hydrated, so you have water.
Okay.
Okay, so we want to find the percent composition of water. So we're going to set up the same thing. Percent water is how many waters in the compound? 4 waters. What's the mass of water? Add it up. 16 plus. So oxygen is 16 plus 1.008, which is hydrogen's mass. You're looking at the periodic table, so total 18.016. So 16 plus 2 basically is 18. Okay, so that's just the water. And then the whole shebang, I'm not going to write it out. Add it up in your calculator with me. What is zinc's mass? 65.39. And there's only 1 zinc, right? There's a subscript of 1 after that, so that's why there's 1 zinc. How many nitrogens?
2.
Hold on. So how many nitrogens?
2 nitrogens.
2 nitrogens. There's a 2, there's a 1 there, so 1 times 2 is 2. So that's 2 times 14. Okay? Plus how many oxygens? 6 oxygens, because there's a 3 times 2, so that's plus 6 times 16 is oxygen's mass, right? And if you've done your problem sets, you've done these, you're gonna start memorizing these specific elemental molar masses like super easy. So that actually makes your time go by faster when you're doing homework. Okay, so that's just zinc nitrate we've taken care of. We still have to add the waters in the molar mass. So add what? Add 4 times 18. If I can work the calculator. What do you guys get as your mass? So this is waters. This is the water over the total compound mass, which was 261.454. I added the 016 here. So it's okay if it's a little off because it just depends on our specific periodic tables we're using. But regardless, 4 waters over the total mass times 100 gives us what percent water? Hold on, let me calculate that real fast. Divided by mass.
27.56.
27.56% water. Okay, if that's the percent water, then what percent is zinc nitrate?
Everything else.
Everything else. So how do you do that? 100 minus that. So that would be like 70, I believe 72.4% zinc nitrate. Because together they make up 100%. Cool? Not hard, it's just tedious because you're like, calculate everything, add it up. Alright, so we have about 20 minutes left. Everybody grab a Chromebook. Chromebook.
Chromebook. If you want to work with a partner, then grab one Chromebook. If you want to work with a partner, then fine. Go to my website right now.
Go to my website, please and thank you.
Are you taking these Scantrons back up with the
The Scantrons, no. The test, yes. I'll get it. Yeah, you can throw it up there. Okay. A lot of stuff are actually, if you still have your calcium carbonate lab, you can run in the back of this. If not, pull out a separate sheet of paper. I'm going to do this one with you, and then while the computers are pulling up, and then I'll show you where the stuff is on my website. Logs, yeah, your computer should be pulled up open when I ask you to log on, because if not, it takes a long time. Okay, so you have a piece of paper out for this. This is called the simulation. Okay, this is our percent hydrate. Percent hydrate simulation. These are pre-lab questions, but I want to do one of them with you, and then I'll see if you still need more. But I don't think you will. If you want to do it once per group, if you don't finish, though, you guys are going to finish together, or you can finish separately. So if you write on separate sheet paper, it's easier that way. All right. So title this percent hydrate simulation, and I want to talk about number 3, a couple of them here before you start the simulation. The simulation is very quick. So that's why I'm hoping that you guys are with me here, okay?
and you want to do it?
The pre-lab, yeah, the only one I'm asking for right now is this, so you understand the terminology used. So whenever they say hydrate, what does that term mean? Water's embedded in the crystal, right? It's a crystalline structure. So like previously, so here's an example. Barium hydroxide octahydrate. Barium hydroxide octahydrate. Or one we just said was zinc nitrate tetrahydrate. One we've used before is copper 2 sulfate pentahydrate. So it sounds like a foreign language, but it's not. We know the language now. But anyway, if it's hydrated, that means that it has dot, number of water. Oops, that says 50. Number of waters in it. So this just means that it has waters embedded in the crystalline structure in the salt form. What does anhydrate mean, or anhydrous?
No.
Right, because an, that prefix means without. So without water. So how do you get water out of something, do you think?
You heat it up.
You heat it up, and it dehydrates, right? That's exactly what the simulation is. It's a little crystalline structure. You heat it up. You start off with one mass, but after you heat it up, the water escapes. The water goes away. What happens to the mass? It goes down by how much?
However much.
Less the hydrate water that was that went away.
Right, so whatever the mass of water in the sample goes away. So whenever you dehydrate it, it goes to the anhydrous form, which is without water. So, for example, the one that we just did previously, we had zinc nitrate 4 waters. That anhydrous version would be what? Just zinc nitrate. No water. Okay, so when you get on the website, go to Unit 4 Documents. So I just did the one pre-lab question I wanted you to do. I did it with you. So you should have some of that, the whole term hydrate versus anhydrate down. I will put this back up here just a second. I hope you guys are listening. I'm not going to explain again. It looks like this when you get to the website. It's under Documents 4, Unit 4, percent composition simulation. It looks like this on the data table. The data table specifically is what I need from you. Okay, this I'll ask for you to be done by Monday. I expect you to finish most of the data collection part today because it's just a simulation. So, do what you gotta do.
Oh, you want to answer a lab question?
Yeah, answer. No, not the lab question. I have the only lab question I want you to do. I want you to read the lab. Yeah, I will. I want you to read the lab first, which is just some background information. but it tells you what to do in the simulation here. The link is right there.
Are we going to eventually do the other three lab questions?
I feel, I mean, if you want to, that's fine, but I'm trying to diminish y'all's work. So, if you need it though, please do go back and do it. Here's that other question. I just did the one I wanted to do with you guys. We spent a little longer since lab was going through. I'm saving this part up right now. Okay, we can come back and feel.
You have to lay tomorrow.
I was just reading about it.
You said you have TOB.
I have till this one, yeah.
One paper. Do Monday. Yeah.
Oh, yeah, I'm sorry.
I already had some people give me like, what am I doing here? This right here, G and H, are literally from the periodic table adding up the molar masses, okay? That part there does not even require the simulation. It's these parts here where you're going to find data from the simulation. Those three, everything else you can calculate afterwards. So, I told you the simulation part's real fast. So this is just PTOE adding up.
I just think
Guys, you may have realized if you do the simulation over and over again, it gives you different masses every single time, so nobody's gonna have the same answer unless you do the simulation together. Yeah? So if you do it again, watch your numbers, because it might be a different number. So that's why, like, literally, write down the number you see right now, and everything else past that is just stoichiometry. You literally have to look at that simulation one time. That's it. It's just the handout sheet on there is what you need to see for data. This is your mass carbohydrate, so so you can A rhythm data table, that's what that is. And then B is the final mass carbohydrates, so the difference between that is the amount of water that has water in it. So carbohydrates is water. And anhydrous is without water. So you can take the percent original final storage from the solution without storage. You see where it says B and star and C has a star and A has an answer. So you have B mass. Or like after that. So, yeah, because what happened is once you dehydrate the sample, now wait, that was from the last one. That's the mass B and the mass B.
No, the mass C right before is the mass. Well, that's what. So B is it? No, the mass of the. It's without water. What I was at.
So it's on B and C has a little star on it.
So the mass of the ATM. Oh, that's not. That's the difference.
Yes.
And then this is just the same.
That's the final mass of the heated this.
Yeah, see what's happening.
The water temperature is still on
So now I just do but you should be over 700. Yeah, so what happens tomorrow?
So that mass will be 0.
Water does evaporate out, right? So the total is the amount of water.
So if you put the mass of the copper in for the initial mass.
Basically the mass of this divided by the mass of everything. Mass.
afternoon, Chargers. The Pink Out Coin Drive has been very successful so far this week. Currently, Miss Dellinger's class is in the lead, followed closely behind Miss Parada, Miss Escalera, Miss Hunter, and Miss Church's classes. Tomorrow is the last day, so make sure you bring in your money.
Did you do no, 64 plus 30. Yeah. Yeah.
Yeah, that's the recommendation. So this would be more mass.
Applies on.
Should be logged off now. You should have your data. You should have your data. Chromebook's gotta go up for me.
Yeah, that's the percentage.
Yeah.
Alright.